Welcome to Introduction to Logic, Unit 2, an introduction to Aristotelian deduction. This is Lecture 2, Part 1, the square of opposition and immediate inference. In this short video, we'll learn about the logical relationships between the four categorical propositions and how we can use those relationships to form the so-called square of opposition, which will in turn allow us to make immediate deductive inferences. In our last video, we learned about the four categorical propositions: the universal affirmative, the universal negative, the particular affirmative, and the particular negative. As an example, here we're using dogs as the subject term and mammals as our predicate term. So we see all dogs are mammals, no dogs are mammals, some dogs are mammals, and some dogs are not mammals. We also learned about the concept of distribution in the last video. A term in a categorical proposition is said to be distributed if the proposition makes a claim about the whole class or set of things in that term. We saw that the A, the E, and the O propositions all contain distributed terms. In the A proposition, the subject is distributed. In the E proposition, both subject and predicate are distributed. And in the O proposition, the predicate term is distributed. We also learned a little bit about Venn diagrams in the last video and saw how we can use these diagrams to visualize the logical relationships between the subject and predicate terms of the categorical propositions. We'll learn more about Venn diagrams when we get to Lecture 3 in this unit. I also have a video that covers only Venn diagrams in the playlist, so you can check that out later too. Now, looking at our four categorical propositions, we see that there are a lot of ways that we can organize them. But given that there are only four of them, putting them in the form of a square seems aesthetically appealing. But as it turns out, there are other benefits from putting our categorical propositions in a square. By comparing any two categorical propositions together, we discover an interesting and useful set of logical relationships. In the first video, we were talking about the relationships between the terms within a single proposition. Now we're going to compare pairs of propositions and discover that we once again have interesting logical relationships. Let's begin by thinking about the distinction between the quantity and the qualities of our propositions. When we think about quantity, we see that our propositions can be distinguished into universal and particular classes. Two of our propositions are universal in quantity, that is, the universal affirmative and universal negative, the A and the E, and two are particular, the particular affirmative and the particular negative, the I and the O. Perhaps this reflects an unconscious Platonic bias, but let's put the universals on top and the particulars below. Of course, Aristotle held that universals, or secondary substances, contained all the common properties of particulars, so maybe this is not just a Platonic bias after all. With a quantitative distinction in place, we can now turn to quality. Our four categorical propositions all have a quality as well as a quantity. So if we distinguish them by their affirmative or negative nature, we arrive at a four-fold division along horizontal and vertical axes. This division between quantity and quality forms a relational square: universals on top, particulars on bottom, affirmatives to the left, and negations to the right. Notice that the distributed terms are still indicated in bold lettering to remind us which terms are distributed and which aren't. This is a really important concept to get into our minds, as we're going to need this concept of distribution when we get ready to put together syllogisms. This arrangement is what we call the square of opposition, and this topology is not just aesthetically appealing. It also reveals four distinct logical relationships that will enable us to make immediate valid inferences based on which pairs of propositions we're considering. If we start with the universal affirmative claim, we can compare it with the universal negative, or we could compare it with the particular negative, or we could compare it with the particular affirmative. Of course, we could also start with the particular affirmative and compare it to the universal affirmative or the universal negative or the particular negative. As a matter of fact, we can start anywhere on the square we like and compare the logical implications of the given proposition with the other three, assuming that the subject and predicate terms are uniform throughout. We're going to start with the most intuitive relationship and the one which gives us the clearest sense of opposition, which is part of the name of this whole game. A and O and E and I, or if you prefer, I and E and O and A, notice that the lines are bidirectional, form what we call the contradictory relationship. Contradiction is easy to remember because you already have an intuitive concept of its meaning. Opposite truth values. On the square of opposition, A and O, E and I will always have opposite truth values. If it's true that all dogs have tails, then it must be false that some dogs do not have tails. Similarly, if some swans are white is true, then the claim that no swans are white must be false. These propositions are contradictory to one another. Whatever the truth value of one statement is, its contradiction will always have the opposite truth value. Of course, determining what the truth value of a statement actually is a matter for empirical observation, not of logic. But here, we're interested in the logical relationships between the statements, not their relationship to material facts. That comes in later. But what about the relationships between the universal affirmative and universal negative claims? Surely they're going to be opposites too. As a matter of logical fact, the universal propositions are not contradictory to one another. They are contrary to one another. Certainly, it would have to be the case that if all dogs have tails, then the claim that no dogs have tails would be false. But suppose it was false that all dogs have tails. Would it follow necessarily that no dogs have tails? Certainly not. It could be the case that some do and some don't. So the logical relationship between universal propositions does not entail opposite truth values. These statements are contrary to one another, meaning that they cannot both be true at the same time. However, they can both be false at the same time. Or as Abraham Lincoln noted to himself in the heat of the American Civil War, quote, "In great contests, each party claims to act in accordance with the will of God. Both may be, and one must be wrong." Unquote. So it seems that Aristotelian logic can be useful even to presidents, if they have the will to use it. The logical relationship between the two particular propositions is the mirror opposite of the relationship between the universals. We call it the sub-contrary relationship. If it's not the case that some dogs have tails, then it must be the case that some do not. This relationship requires that at least one of the two claims be true, although it does allow them to both be true. However, they cannot both be false. That will be logically impossible. This is exactly the opposite of the contrary relationship we saw between the universal affirmative and the universal negative statements. Let's suppose that someone asserts that an I proposition is true. It would be impossible for us to know if the O statement was true or false, since they both could be true at the same time. We'd simply need more information to determine the truth value of O. But if someone asserts that an I claim is false, then it must be the case that the O is true, since at least one of them must be true. The final logical relationship is derived by comparing a universal to a particular or a particular to a universal when they have the same quality. For example, if it's true that all dogs have tails, then it must also be true that at least one dog has a tail. Truth flows down from the universal to the particular. Whatever is true of a whole set must also be true of each particular member of that set. Similarly, if it's true that no fish have feathers, then it must also be true that there's at least one fish that doesn't have feathers. The truth of the universal entails the truth of the particular. But in sub-alternation, the inverse is not the case. If it's true that one dog has a tail, it doesn't follow that they all do. Truth only flows down in sub-alternation, never up. However, falsity does. If it's false that there's at least one dog that has a tail, it certainly must also be false that they all do. The same is going to hold true for the relationship between the particular negative and the universal negative. It's easy to remember the direction of the flow of truth value in sub-alternation. Truth is like gold. It's heavy. If you drop it, it falls. It goes down. But false claims are like the promises of politicians, just so much hot air. And what does hot air do? It goes up. So truth goes down, falsity goes up. Keep that in mind and you'll have no trouble remembering sub-alternation. By examining the relationship between pairs of categorical propositions, we find that there are 4 definable relationships on the square of opposition: contradiction, contrariety, subcontrariety, and subalternation. And as you've no doubt already noticed, these relationships are extremely useful to understand. Taking any one of our 4 categorical propositions as a starting point, we can use those definitions to make immediate logical inferences regarding the other claims, and these inferences will always be valid based on the definition. That is, we will be making logically necessary conclusions based on the definitional truths or the definitional values and the initial truth value assignment of the proposition we use as the premise in the argument. Now, let's do some practice, just again to see how all of this works, just to get it clearer in our minds. We begin by setting up our square of opposition. Always remember to be sure to have your universals on top and the particulars on bottom. That is, the A and the E go on top. Also, remember, the affirmatives go on the left and the negatives go on the right. Let's begin with contradiction, which is the easiest of the definitions to remember. Let's take an A proposition like all humans are mortal. Now, for the sake of argument, let's give this proposition a truth value assignment. That is, we're going to assume that it's true. So it has a true truth value assignment. What do we know must be the case regarding the particular negative claim containing the same subject and predicate? That's right, it's going to have to be false. If all humans are mortal is true, then the assertion that there's one human who's not immortal would have to be false, because these are contradictory claims. But what if it's true that there is at least one human that's not immortal? Then it must be false that all humans are mortal. The truth of the particular negative undermines the truth of the universal. That's one of the reasons we should always be very cautious about making universal claims. It only takes one counterexample to prove that the universal claim is false. If we claim that all swans are white, but then we find just one black swan, our initial claim must have been false. We see that exactly the same thing is going to be true between the particular affirmative and universal negative. If it's false that there's at least one dog with a tail, then it must be true that no dogs have tails. This is a valid inference which we can make immediately. That is, without any other information necessary, because the I and the E propositions are contradictory to one another. They will always have opposite truth values. And of course, the same is going to hold in the opposite direction. The truth of the E proposition necessitates the falsity of the I proposition. So the contradictory relationship is the easiest one to remember, because any pair of claims that are logical opposites must have opposite truth values. Now let's practice immediate inference based on the contrary relationship. Remember, they can't both be true, but they can both be false. If we again begin by assuming that a universal affirmative is true, that is, the A proposition is true, what can we validly infer about the universal negative? Correct. They cannot both be true at the same time. So if A is true, E must be false. Now what about the opposite position? Suppose it's true that no dogs have tails. Then it must be false that all dogs have tails. Universal propositions of different qualities cannot both be true simultaneously. Next, let's assume that it's false that all dogs have tails. Let's give it a false truth value assignment. What can we infer about the claim that no dogs have tails? Nothing. While both universals cannot be true simultaneously, they can both be false at the same time. So in this case, we'd say that E is undetermined. Remember, we're doing immediate inferences on the square of opposition, so we're asking ourselves what must be logically true based on only one premise. That is, the categorical proposition that we start with. We'd get exactly the same outcome if we started by assuming that the E proposition is false. We cannot logically know the truth value of A if we start with the assumption that E is false. A would be logically undetermined. Contrary propositions cannot both be true simultaneously, but they can both be false at the same time. Now let's practice the subcontrary relationship, which is the converse of the contrary. Subcontrary propositions cannot both be false, but they can both be true. Or another way of thinking about it is at least one of them must always be true. So if we begin with the assumption that there is at least one dog that has a tail, that is, we're going to give a true truth value assignment to the I proposition, then we want to know what will be the case with the O proposition. The answer is nothing at all. It might be the case that all dogs have tails. It might be the case that there's only one dog and it has a tail. When we assume that I is true, we've met the sufficient condition of the subcontrary relationship. We've got at least one of them that's true. But that doesn't help us to know what the truth value of its opposite particular claim will be. The O would be undetermined. The exact same outcome follows if we start by assuming the truth of the O proposition. Since they can both be true, that means the other one might be true, or it might be false. We cannot make an immediate inference regarding the truth value of I. So in this case, again, we'd say that it has an undetermined truth value. Now let's suppose that an I proposition is false. If that's the case, O must be true, because in the subcontrary relationship, at least one of them must be true. So if we start off assuming that one claim is false, in this case the I proposition is false, then we can immediately infer that its opposite must be true, because at least one of them has to be true. And we'd see exactly the same thing here. Subcontraries cannot both be false, and at least one of them is going to have to be true. So the subcontrary relationship is the mirror opposite of the contrary relationship. At least one of them must be true, and they cannot both be false. Finally, let's practice the sub-alternating inference. Remember, truth is golden, and gold is heavy, and heavy falls. Falsity is like just so much hot air. And what does hot air do? Hot air rises. If it's true that all dogs have tails, what can we necessarily infer about the claim that there's at least one dog with a tail? It must be true. The truth of the universal entails the truth of the particular. Now, we should briefly note here that this entailment only works if dogs actually exist. If there were in fact no dogs at all, then how could it be the case that there is a dog without a tail? Or for that matter, with a tail? It wouldn't matter. This is called existential import, and we'll discuss it more fully in the next video. Next, let's suppose that it's false that all dogs have tails. What does that tell us about the claim that there's at least one dog that does have a tail? Nothing at all. In this case, it would be logically undeterminable by immediate inference. After all, perhaps no dogs have tails. The thing to remember is that false truth value only goes up in subalternation, never down. That's because falsity is like hot air rises. Just because something fails to be true of a whole class of things doesn't mean that it may not be true of an individual member of that class. Now, if it's true that there is one dog that has a tail, is it also true that all dogs have tails? Of course not. The truth of the particular claim does not necessarily entail the truth of the particular. This would be the worst kind of hasty generalization. Just because something is true of one thing doesn't mean that it's true of all of the things of the same kind. Now, let's take this case. Let's assume that it's false that there is at least one dog that has a tail. What must be true of the A proposition? That's right. It must be false. If there's not even one dog that has feathers, it certainly must also be false that they all have feathers. The exact same thing is going to be true of the E and the I propositions. The truth of the universal necessarily entails the truth of the particular. The falsity of the universal, however, does not entail any truth value for the particular. It remains undeterminable. Falsity doesn't go down, it only goes up. The converse is also true. The truth of the particular does not yield a truth value for the universal. If we know the particular negative is true, we don't know anything about the universal negative's truth value. It is logically undeterminable on immediate inference. But the falsity of that particular claim is, like so much hot air, always going up. It always rises. So if a particular is false, the universal of the same quality will also be false. This is the subalternating relationship. It's a two-way street, or it presents bidirectional truth value depending on where we start. Now, let's put all of this together. Let's suppose, just for grins and giggles, that we assign a true truth value to a universal affirmative proposition. Let's say, for the sake of argument, that it's true that all dogs have tails. What can we deduce from this assumption? Well, if we consider the E proposition, that is, no dogs have tails, we see that it simply cannot be true. And that's because these propositions stand in a contrary logical relationship. Now, what about the claim that there's at least one dog that doesn't have a tail? It too must be false because it is the contradiction of all dogs have tails. Thirdly, if we're assuming that all dogs have tails, what does that tell us about the claim that there's at least one dog that has a tail? Well, it must be true as well because of subalternation. The truth value of the universal falls to the truth value, or becomes the truth value, or entails the truth value of the particular. Now, if we were to start with a universal negative being false, we wouldn't have as much luck as we did in the last example. The universal affirmative would remain logically undetermined, as would the particular negative, because falsity just doesn't go down. But if we assume that the universal negative is false, we would know at least one thing. We would know that the particular affirmative claim would have to be true, since contradictions always have opposite truth values no matter what. So, how much of the square of opposition we can solve, or the number of immediate inferences we can make, is based on which proposition we begin with and what kind of truth value assignment that we give it. In this brief video, we've learned about the square of opposition, which is defined by the four logical relationships that exist between our categorical propositions. We've learned about contradiction, contrariety, subcontrariety, and subalternation. Understanding these relationships allows us to perform immediate deductive inferences, or to put it another way, it allows us to make valid deductions based on just one premise. In our next video, we'll spell out these valid deductions in more detail, so be sure to check out the next video in this series. See you then.